So, thank you very much, and hi everyone. So, I'm happy to talk to you about, well, platform engineering today, or alternatively, why Kubernetes is great for building platforms. So, I'm Niklas, I'm from Google, specifically Google Cloud, and have been, well, working on and off around Kubernetes for about 7 or 8 years now in roles such as, well, platform engineer, essentially. So, first off, just to give you a rough agenda, what I will be speaking about, like this talk developed a lot over the past months because I found it really hard when I introduced people like this. Everything I will talk about today, there will be code at the end, but it was really hard when I tried to convey the whole concept of a platform with code, because there's a lot of code, there's a lot of CNCF projects involved, a lot of YAML, more YAML than you need potentially. So we will start off with kind of definition of platform engineering. What does it mean to me, potentially others, just so we have a joint definition. Then we will dive into a fictional company, a company I might or might have not worked for before, who knows. And we will talk about team topologies, how applications are delivered, kind of the decisions behind application delivery and policies and guardrails, and why this company decided to build a platform in this way. There are more topics to cover, but I really focused on, let's say, the surface area that is most relevant for developers here today. So there's lots of like secret management we will not cover today, essentially. And after we went over the tech, we will dive deeper into like some architecture diagrams and see how like the composition actually works when you look at the whole bigger picture. So there's a lot of diagrams today, but no code. I also excluded YAML, so there will be a lot of custom resources. You just have to Google them yourself, and hopefully I can still convey the concepts behind it. And last, I kind of want to conclude why Kubernetes really works great for such use cases, and then hopefully you have a lot of questions, and hopefully you're already somewhat familiar with Kubernetes, because there will be a lot of Kubernetes today. So what is platform engineering? And because I didn't want to come up with my own definition, I just picked basically two quotes here. So Evan Botcher, who's head of engineering at ThoughtWorks, basically stated, according to him, a platform is a foundation of self-service APIs, tools, services, knowledge, support, which are arranged as a compelling product. And autonomous delivery teams, so application developers, streamline teams, however you want to call them, can make use of this platform to deliver product features at a higher pace with reduced coordination. And Matthew Skelton, who is one of the co-authors of Team Topologies, stated essentially a platform, which is a way shorter term, is a curated experience for engineers, the customers of the platform. But the purpose of the platform team or teams, nowadays you often speak of platform groups actually, not teams anymore, because you don't want a monolith, is to enable stream-aligned teams, product teams, essentially, to deliver work with substantial autonomy, so self-service again. The platform team provides internal services to reduce the cognitive load that would be required from stream-aligned teams to develop these underlying systems. And if we take a look essentially at the list of platform engineering principles that were derived in his book, he essentially talks about platforms as the thinnest viable platform that developers need to build out infrastructure. And that, in a nutshell, can be, if you're in a startup and you have knowledgeable developers, that might as well be just a wiki page. So it doesn't have to be a technical solution. The platform is a product, as mentioned, and application teams are usually the customers, and platform teams own and build like tool chains, developer tool chains, and abstractions around complex infrastructure, like often networking, maybe load balancing, maybe whatever you can imagine. And at the end of the day, a platform provides end-to-end paved paths. Spotify also refers to them as golden paths. What is meant by that is essentially, well, if you have certain patterns like of tools, like backends, you want to develop best practices, and it's a path. So if developers need to deviate from your path, they are actually free to do so. And I think this is at least a somewhat contrast to the platforms we know from like 20 years ago, where you usually buy platforms and they are these huge monolithic things, and that's not what's meant by platform engineering nowadays. You try to be more customer focused, so it's not about you, maybe as a platform engineer, maybe with a stronger operational background, developing something that you think is sensible, but really doing more product management and really building something that is useful and joyful to use for developers. And why would you do that? And it, to me, boils down to basically three things. Like, you usually want to build something that reduces cognitive load. Maybe there's complexity because you might have complex networking setups in a larger organization. You want to reduce the knowledge developers need to be effective working in this kind of environment. At the end, lowers burnout risks. You want to accelerate developer development. So that might even mean, like you see that in Backstage, providing blue sprints, providing best practices to get started faster. And at the end of the day, you want a faster time to market with lower costs. And third, I think it means guardrails suited to your organization. And I think guardrail needs to be there needs to be a distinction between a guardrail and gatekeeping. A guardrail means you give basically a guided path, but developers can still jump over the fence if they think it's sensible and there might be some value on the other side. And it will usually improve security and governance in your company. If you have standards of how you interact with secrets, best practice for certificate management, then usually there's always some gain from it by not everyone doing it differently, by standardizing. And why actually do it on Kubernetes? From my point of view, I've worked with Kubernetes for a long time. I like it. I like running it. I like working with it. However, from my experience, there's a high cognitive load required for managing all the configuration in Kubernetes. And often in companies I worked for, there were always some, not all, there were always some people who struggled with the complexity of Kubernetes. And at the end of the day, Kubernetes is very flexible, so you might want to standardize your approach to security, governance, compliance, and you want to specialize Kubernetes more towards your own requirements that you might have that others might not have. If you have a big batch processing system, you might want to build out some platform parts where it makes it super easy to batch process at night, maybe doing some sustainability work as well, where it's more cost effective, or greener energy at night when there's not so many users, or you want to create better visibility automatically in regards to like cross-charging, like FinOps, so you want to make cost visible easily. And at the end of the day, and that's funny because this quote is actually really old by now, I think it's like 4 or 5 years old by now. Kelsey Hightower stated like 4 or 5 years ago that Kubernetes is a platform for building platform. So it's a better place to start, but it's not the end game. So if you're using Kubernetes now, then you really should try to adapt it in a way that you work more efficiently and are not overwhelmed constantly by complexity. And then quickly regarding Kubernetes, I hope most of you know this, but just to recap, how can Kubernetes actually be extended? You have custom resources, so more resources on top, or additional APIs on top of the normal REST resources you kind of have underlying. There's an admission webhook, so basically sitting in between the API server and users. And there's plugins like device plugins, storage plugins, network plugins. We will not cover those today, but there's some actually very interesting use cases specifically around CSI for secret management, like integrating with other KMS solutions and so on. And to make this somewhat more visible and recap once more, let me actually get my laser pointer out. So custom resources are essentially additional definitions for resources, and you have an external new third-party controller. Plugins, in a way, are slightly different. They attach to a standardized interface. They actually usually don't often interact that much with the API server as much as they interact with the kubelet. And then you have admission controllers that are essentially this kind of protective layer around the API server. So the API server basically sends webhooks to your admission controller and says, yes, no, please tell me what I have to do. And that applies to your CD systems, users, and so on. Let me get rid of the pointer. So the fictional company. So the fictional company we talked today about is a fintech called Finicorn. So obviously it's a unicorn and a fintech. When I tried to generate a logo, unfortunately the logo was subtitled with Flinifonch, so we will talk about a company called Flinifonch today. Apparently GenAI not really great with letters. It's an organization that has needs for secure workflows and guardrails just to make being compliant to regulation or customer requirements easier, and has a, let's say, conservative stance on vendors. So commodities, yes. Commodities means to me essentially like you Managed SQL database is fine, you get them anywhere. Managed Kubernetes is fine, you get them anywhere by now. But maybe if there's a proprietary protocol, proprietary workflow system, it's something you would shy away from. But that's is not a showstopper for FliniFunge. If there's really value provided, lock-in is also not an issue for FliniFunge, but they are, let's say, more conservative. Also why we will talk exclusively about CNCF projects today. They have basically application teams and a platform group, and the main distinction is application teams have, let's say, little to no knowledge provisioning infrastructure, but in intermediate Kubernetes knowledge, and obviously are expert application developers. And the platform group have expert Kubernetes knowledge, are usually experts in provisioning infrastructure, but maybe have less understanding of the nitty-gritty details of the software development lifecycle. However, obviously this is fairly black and white. Usually it's more grays and a lot of grays. So if you might have DevOps engineers and application teams still, because you still want to have ownership. They might have deeper knowledge, maybe specifically around application delivery. You might have security engineers in the platform group really going deep into any form of CVEs, requirements, software supply chain security. You might have general platform engineers, Kubernetes engineers, you name it, essentially. It really depends on the organization. So it's usually not that black and white, but in this case, just as an example, it's rather black and white. Then let's talk about how FliniFunge actually decided to do application delivery. Basically, at the core, first touch point usually from developers. And FliniFunge actually decided to adopt Tekton, something you might or might not have heard about. I think that's maybe also for FliniFunge one of the why they should be more cautious around Tekton, is not as widely in use as GitHub Actions, GitLab Runners, and you name it. But it's a project that started as Knative build way back in 2018, was then recycled, don't ask me, and is essentially an open source CI/CD platform implementation, but it's also a spec. So it's an open API spec to describe pipelines. What's interesting about this is there's a couple of, because it's governed by the Continuous Delivery Foundation, there's a couple of companies out there that are planning to implement this interface. So you would have, let's say, less vendor lock-in because you can move vendors that implement this interface. The CDF itself is similar to the CNCF, is a basically foundation part of the Linux Foundation, so similar governance setup essentially, and the vision and mission and the goal of Tekton is essentially to be composable, declarative, reproducible, and cloud native. And for FliniFunge, what is really important here is composability. So composability in a CI/CD system usually means you can have a team that maybe provides building blocks, tasks that can be consumed by other teams. So really aiming in onto this cross-team compatibility and being able to provide building blocks between teams. They really like that it's Kubernetes native, has the advantage if you lock down policies in Kubernetes, you lock them down for your workloads the same way you lock them down for CI/CD pipelines. And the OpenAI spec would potentially allow them to, in the future, be less locked into a specific vendor, but be able to move workloads around if they are cheaper, for example. The second tool they use that most likely you know is ArgoCD. Was created at Intuit, donated to the CNCF in 2020, automates deployment of applications to clusters, follows GitOps operational framework. I would say ArgoCD follows it less cleanly than, for example, Flux, but there's different trade-offs. You can do push and pull-based deployments with it. It's very enterprise-friendly, has lots of nice, fancy UI features. However, what maybe FliniFunge dislikes about it would actually be this additional layer. I think ArgoCD is really great and developers love it. Usually operators love Flux CD in comparison more, but developers really love it. So that's kind of a big thing. Developer experience is great, but the power the UI brings with it is also kind of the pitfall. You might have an additional permission layer that you have to manage on top of Kubernetes. And at the end of the day, they decided to go with ArgoCD regardless. And it's a great project. If we now look at kind of the rough outline from an application side, so you have a code repository and Tekton will go through the code, run a pipeline, clone the code, build an image, do something in between tests. And ArgoCD is basically you have a application in ArgoCD that takes some config from somewhere and applies it to clusters. So if we dive one layer down, and all of these are custom resources in Kubernetes, then Tekton has a task custom resource and has a pipeline custom resource, and a pipeline would reference tasks. This can even work across namespaces. The nice thing is also Tekton is very strict regarding input and output of tasks. So as long as you keep your input and output compatible, it's really nice that you can update tasks independently of pipelines, and pipelines will just leverage those updated tasks as well. There's also like a hub for tasks made by others. And on the ArgoCD side, you usually have the application that links the configuration to a cluster, but under the umbrella of an application project, which is essentially how in ArgoCD you declaratively define permissions, like in an app project, which cluster are you allowed to deploy to, which deployment, maybe which resources are you allowed to deploy, which repositories are you allowed to use, and so on. Maybe which branch are you allowed to use. And then the big question, however, is like ArgoCD really covers only Kubernetes, and ArgoCD can reconcile changes to Kubernetes, which is nice. But what about provisioning infrastructure for our application, or interacting with external resources? Might just be acquiring additional data you might need for like an existing external resource, like a database. And Crossplane defines itself as an open source CNCF project built on the foundation of Kubernetes to orchestrate anything. And it's very similar to Terraform. Essentially, you are able to install providers into your cluster, and then you can basically, similar to in Terraform, you instantiate resources. You can now instantiate resources in Kubernetes, and they are managed from within Kubernetes. However, why Crossplane is actually really great for building platforms is actually another feature of Crossplane that is called compositions. And you can kind of see the composition here on the right side. A composite resource is basically an extended custom resource. To the end user, it appears to be a custom resource, but it can have multiple implementations. And that's actually a really, really nice indirection that Crossplane provides to you, because if we take an example, so simple example, you want a database, maybe you're multi-cloud, so you want to have Postgres database on AWS, Azure, and Google, but you want to provide basically the same interface. So the developer just requests a Postgres database, and you get some secret with credentials for it. And you don't know how it works, you don't know in which cloud provider you are, it doesn't really matter. You just get credentials through this kind of interface, so you can have multiple implementations. But it's even more flexible, because if you want to have cost savings, maybe you have an alternative implementations in your dev cluster, where instead of provisioning a full database instance, a developer deploying to like a pull request environment or some test environment in dev, or his personal test environment, I don't know, then provisioning a Postgres instance might actually not even provision a Postgres instance, but just give you a database in an existing instance just for cost savings. So if every developer gets their own Postgres instance, then you might, pay a lot of money if you have a lot of developers and they work heavily in Kubernetes. The cool thing is you can mix and match. So it's really powerful in the sense that you can mix existing custom resources. You can build compositions out of custom resources provided by providers. Funny enough, they're actually like the providers you see today are cross-compiled or transpiled to Crossplane providers. So if you see the Google provider, if you see the AWS provider, then usually you also see the same resources you see in Terraform. But you can also just create custom, you can use the Terraform module, so you can actually make Terraform modules accessible from within Kubernetes as well. And but you can also just provision Kubernetes resources. And for Flinifunch, this is a great fit, because now they can even use existing Terraform infrastructure, build interfaces to existing Terraform infrastructure with Crossplane, and make this accessible to developers. They can provide features with Crossplane to developers, and they can implement them in different environments, multiple vendors potentially, or for different use cases, with the same user experience for the developers. Then let's jump into policies and guardrails. So platform tends usually to the developer's need, but you also for your common use cases might want to establish best practices, and for that you often need policies and guardrails. Flynifonj decided to use Kyverno, so you probably have already heard of like Open Policy Agent. Kyverno is basically another CNCF project. The main difference is Kyverno uses policies as custom resources with no new additional language, and that was also the main driver for Flynifonj to use Kyverno, because Kyverno is simpler. You have custom resources, which always at the end of the day, the Kubernetes API server actually computes a full open API spec for everything in your cluster, which means you have really hard, fully typed definitions of policies. You don't need to learn a language, and you don't get weird errors when you just apply like a policy with the policy language in there, and you only notice if stuff doesn't work. So Kyverno policies can validate, mutate, and generate and clean up resources. The last one is actually interesting, it's rather new. I think they added it beginning of this year. So you can also use it for like cleaning up developer setups in a dev cluster automatically or similar things. But it can also nowadays verify image signatures and artifacts, so specifically for the supply chain use cases. If you want, you can use their CLI, test policies, validate resources as part of CI/CD, but I won't really cover this today. It's also not in the code, actually, because I didn't use it. And in practice, it looks somewhat like this. So Kyverno, at its heart, is an admission controller. So everything that goes into your cluster, Kyverno will be asked, hey, am I allowed to do this? And Kyverno will basically compute the policies based on the custom resources you have in your cluster. There's a policy custom resource, and you define what kind of policies apply in your cluster. And Kyverno will basically say yes, no, maybe a warning. In dev, you might just emit warnings instead. And it will produce events, potential resources if you generate them, but also generate like policy reports so you can actually monitor your policy usage. Now, jumping to basically image attestation and kind of covering what like software supply chain security is at its heart. For me, to put it really, really simple, software supply chain security without going deep into any of the tools is about establishing trust, verifying trust, maintaining trust. You want to establish trust on your supply chain, your dependencies. You want to establish trust for whatever you build. You want to verify trust when you deploy, and you have to maintain trust while everything is running. And how basically Flynifonj decided to do it is they use Tekton chains. So one of the main drivers to actually adopt Tekton was Tekton chains, because Tekton chains is a supply chain security add-on for Tekton. It observes everything that happens in pipelines, takes snapshots, will convert them into payload formats like in toto. So in toto is like a JSON-based format for attestations. It signs them with your own key or maybe an existing KMS system from a cloud provider or HashiCorp, doesn't really matter, and will store them maybe next to the artifact in your OCI registry, which is the most common use case. What Flynifonj really likes about this is there's no change to developer experience. What that essentially means, Tekton changes this external resource that watches what is happening in your CI/CD system and will attest whatever happens. Means if there is like an artifact produced, like an image, in the attestation, you can say, is this image from the master branch? Because like everything is signed into the attestation. Is it from the master branch? Did it go through testing? Was it approved by the correct keys? Was it signed by the correct keys? Whatever you can imagine. And under the hood, Tekton chains uses like the same Sigstore, cosign, utilities, and so on, but developers don't have to implement those yourself. So that's actually a big benefit of like a Tekton setup, in my opinion. And then on the Kyverno side, because Kyverno supports image verification policies, essentially when there is like a pod admission going on, Kyverno will go check the image, check the attestation in the container registry for the hash of the image, essentially, and the policy that defined allowed attesters and rules will be checked, and if everything's good, then maybe you're allowed to use it in production, but you might not be able to use an image that's from like development branch in production or something like that. If you want to look deeper into, let's say, the more, compliance requirements behind it and what big companies are looking at it, I would recommend you look at Salsa, but I didn't want to cover Salsa today, but Salsa is interesting if you want to certify how things are going into production. Salsa is really interesting. A lot of CNCF projects are starting to be covered by Salsa requirements. Now, hopefully the most interesting bit, and hopefully I didn't lose you until here, let's look at some diagrams. If we put everything together, then we might have like components used like this. And let me take my laser pointer. So here I have a project shared. What you have to understand if you're not familiar with Google Cloud, a project in Google Cloud is essentially an account in AWS or Azure subscription, so some form of logical unit that contains billable resources, if you will. And in the first one, in the shared project, you have a cluster where the CI/CD system runs, where ArgoCD runs, where Tekton runs, and then you have essentially environmental clusters, so for different environments like dev, staging on the right side, where you have basically applications. So we're kind of separating some, let's say, platform services from the individual cluster, but they're still in-cluster components. There's also components I intentionally didn't cover because I hope everyone is somewhat familiar with them. There's Cert Manager, very popular project, kind of nearly, I don't know who doesn't use it nowadays. And there's external DNS. So Cert Manager does TLS certificates. External DNS basically does DNS records for your load balancer automatically. And in every cluster, you have actually cross-plane compositions available that are managed by Terraform, covered by platform teams, but everything apart from it in Kubernetes clusters, also the platform team components in clusters are actually covered by ArgoCD. Then if we take a different angle now and look at it from the kind of application developer side, the application developer has obviously code and some config in the same repository or different repositories, doesn't really matter. And the code is used by a pipeline that then pushes some artifact in artifact registry with the attestation. You also have some configuration that is referenced in an ArgoCD application and deployed somewhere. And when you deploy somewhere, you might end up with the deployment, vanilla Kubernetes deployment, an IAP service, not native to Kubernetes, but something provided by the platform, which would be a service that automatically has an identity-aware proxy in the middle. So on development, you might still want to expose every service publicly, but you don't want to be it accessible by the public compared to production. So you might just want to put a different authentication proxy in between, and that's kind of hidden away. And the ingress is actually pointing to this IAP service, but you also additionally might have a Postgres running somewhere, and then you might have a concept, and every cloud provider, this kind of concept exists of workload identity. So you want to give the basically the deployment access to the database. So they're usually workload identity systems in cloud providers. So you want to essentially link a Kubernetes service account to permissions somewhere else, usually with OAuth2 federation and so on. And if we then dive into kind of a more topology view on this, you would have the application team working on the left side. Maybe there's a CI/CD team that kind of works a lot on delivery. DevOps practices might not even be a team. Maybe it's just like a DevOps practice with like all the DevOps engineers from different application teams. But you might be a company that is so big they actually still have a database team. Who knows? I miss them somewhat. I'm not too fond on managing databases myself. You might have a connectivity team that builds this auth proxy, but might also take care of like an API gateway, load balancing, and other network requirements. And you might have a general Kubernetes team that manages like Crossplane, maybe some like Cert Manager and other resources. And if you're a smaller company, they all might be the same team. Doesn't really matter. But once you scale, usually you will see teams split up, and then you usually refer to them as a platform group. And now if we hopefully I don't overwhelm you here, dive really deep, then it might look like this. So when we now basically unfold the resources we have seen, then there's some code on GitHub, and you have a Tekton pipeline that pulls the code because it was triggered. Like usually these external CI/CD systems use like GitHub webhook features to trigger pipelines. So they get the events and then trigger like merge request pipelines or whatever you want. And this pipeline might use tasks like the git clone task, like build an image task that was actually created by a platform team. The platform team has the Tekton chains component that when a pipeline actually builds something, will attest the build, like tell you everything that happened to this build, before this build, whatever led to this build. And the ArgoCD application is basically picked up by ArgoCD, which deploys the application to a Kubernetes cluster. And everything that is deployed to a Kubernetes cluster is then governed by Kyverno, which might emit warnings or gate some features that you really don't want people to use. Maybe you want to shy away from pod security policies because they are, well, deprecated and stuff like that. So you can enact policies on older clusters. Maybe even if they are still supported, you could actually already stop allowing older API versions in clusters before an upgrade, just to make sure everything's compatible. And then you have your application deployment, which is just a Kubernetes deployment, but it might reference the service account that is actually created by the Crossplane composition workload identity, which gives this Kubernetes service account that is created through the composition, links it up to a Google Cloud service account with access to the Postgres database. And in a similar vein, the Postgres custom resource that is created by a Crossplane composition might, at the end of the day, give you as output just a secret, Kubernetes secret, with credentials to the created database, so you can connect to the database. And then, similar, the identity-aware proxy service will actually create a native Kubernetes service under the hood that is used by the load balancer, but with the identity-aware proxy. In this case, it's the Google Cloud feature identity-aware proxy, but you could just schedule your own deployment in the middle, or have an existing deployment, use a forward auth hook, or you name it. But we'll essentially do the changes required to have a proxy in the middle without the developer knowing anything about the proxy. So the developer, one annoying thing about these proxies usually is, like, per new subdomain, you have to do like a new OAuth client, and you have to pass like the credentials around, and you don't have to do any of that if you automate it away, essentially. And in a similar vein, something we didn't really talk about, or not much, you would have Cert Manager and external DNS creating the TLS certificate and DNS record for the ingress, so the developers deploy. If the database is not there, it will take a while, and then you have a fully working, publicly available setup with authentication in front, and the developers really have to only care about the kind of red bits in this diagram. And now, to kind of wrap it up, Kubernetes as an identity provider, and I hope you kind of see the value, but I think the primary value is Kubernetes is an extendable API, and developers are familiar with APIs. You can build tooling around the Open API spec if you want, but you can really create like a developer control plane if you use Kubernetes as internal developer platform. And at the end of the day, developers are familiar with APIs, and it should also, maybe as a side note, if you really want to drive Kubernetes as developer control plane, really start teaching the core functionality of Kubernetes. Because I think at its core, Kubernetes is actually really simple. It's an API server, it's extendable, you have controllers, you have like this open API server on steroids. And if developers understand this kind of interface and how to interact with it, it gets not simple, but I think approachable, specifically because Kubernetes is usually the tool they have to work with if you are a company adopting Kubernetes. So you don't have to introduce multiple paradigms, like you have a second repository with Terraform modules, and the life cycle is somewhat connected to the application, but now you have two CI/CD cycles, essentially, that are somewhat coupled, and Crossplane is really a tool to kind of bring an application bundle together. So at the end of the day, you saw the resources I mentioned. You have a bundle that both contains the application, but also defines the requirements to the environment that it needs to run. And I think that's a really, really powerful concept. And it's really nice that Kubernetes allows you to essentially decouple those APIs. So if you scale up, like, those capabilities can be introduced by multiple teams. And I think that's a really powerful concept, because you need to apply the same principles you apply to product teams, to platform teams. At the end of the day, if the argument is you want to, like, application teams lose momentum the bigger they get and the stronger they are coupled, the same applies to platform teams. So if you have a big platform team at some point, you have a platform monolith, and that's also not desirable. So really try to decentralize here. And I think a really nice conclusion that also kind of resonates with what Kelsey Hightower usually says about empathetic engineering is design platforms to reduce toil and increase joy. And I think a really interesting anecdote, because it's somewhat related to speaking about paths or golden paths, is actually park rangers in like national parks in the US or somewhere else. They have a concept, you can look it up on Wikipedia as well, of desire paths, because park rangers, when they see like a people taking shortcuts. They are not like, oh, it's the people's fault, we need to build a new fence, but rather the path layout was wrong. So really meet your customers where they are and don't build something that they don't need. There is occasions where that might make sense, but then maybe consider, I talked actually yesterday to a friend about this, if you talk about staff engineering, really make sure to have the organizational leverage to enact changes that you want to force on people, but try to not force changes on people. And then lastly, this is the repository. It's freely available. It's still in development. The old demo was called Dogcat. So if you want to play Snake with two ends, where one end is a dog and the other end is essentially a cat, and they eat different food, then that's kind of the application in there. But it's created in chapters, so there's more and more documentation, but I was kind of focusing on this presentation to be somewhat consumable, and I didn't manage to make all the code, it's thousands of lines in those two repositories, to make it somewhat consumable. So hopefully today's approach gives you the overview. You might need to dive deep into the code. And finally, if you're really on the edge of Kubernetes as a platform, then watch out for KCP.io. I think it's KCP is another CNCF project, and I think they really solve some pain points around Kubernetes. What you saw in the architecture was like every cluster needs cert manager, every cluster needs external DNS, and KCP kind of approaches this the other way around, where you can have controllers that cover multiple clusters, but you can also unify cluster access for developers as you need. So like you have 3 clusters for dev, but they don't know, well, they essentially don't know which cluster they are using. You can unify multiple clusters, and you can do it for controllers, but also for developers. Really, really cool project. And with that, and just on time, essentially, thank you very much, and questions?
Yeah, thank you very much, Niklas. So sadly, we do not have time to answer the Slido questions, but I got one question in, which is, can you share the slides? So maybe you could put the slides on the GitHub.
Yeah, sure.
And then I would wish everybody a very good day, and one more applause, please, for Niklas.